So now we move on to the Goodman-Kruskal gamma statistic G. The gamma statistic G introduced by Goodman and Kruskal serves as a measure of association specifically designed for ordinal variables, which can determine both the strength and direction of association. Other coefficients like Spearman's rank order, correlation, or Kendall's tau can also assess association. The gamma statistic is particularly advantageous when dealing with data sets containing numerous straight ranks. So consider two ordinal variables, A and B, with values arranged by magnitude, such as A sub 1 is less than A sub 2, and A sub 2 is less than A sub 3, and so on. And B sub 1 is less than B sub 2, and B sub 2 is less than B sub 3, and so on. Within each pair of observations, there can exist either an agreement or disagreement in ordering. Pairs of observed instances given by A sub I and B sub with B sub J and A sub L with B sub M can be classified as concordant, discordant, or tight pairs. So for concordant pairs, these are pairs of observed instances whose ordering are in agreement, and both variables in one case are higher or lower than the corresponding value for the other instance, while discordant pairs are pairs of observed instances whose ordering are in disagreement. In other words, the value of one of the variables in one case is higher or lower than the corresponding value for the other instance. And lastly, we have the tight pairs, which are pairs of observed instances whose value is the same on one or both variables. So, for example, suppose that we have arranged the categories for variable A and variable B by magnitude, and the pairs of observed instances are as follows. We have the first example, we have A1 with B2, B sub 2, and A sub 3 with B sub 4, which are concordant pairs since we know that A sub 1 is less than A sub 3, and B sub 2 is also less than B sub 4. Hence, in both variables A and B, the first pair of instances is less than the second pair of instances. Next, we have A sub 2 with B sub 1, and A sub 1 with B sub 2, which are discordant pairs since A sub 2 is greater than A sub 1, but B sub 1 is less than B sub 2. So for the variable A, the first pair of instances is greater than the second pair, but for the variable B, the first pair is less than the second pair of instances. Lastly, we have A sub 1 with B sub 2 and A sub 1 with B sub 3, which are tight pairs in A, since both pairs of instances have A sub 1. So the population parameter gamma represents the difference between two probabilities, the probability of concordant pairs in which the ordering of A and B are in agreement, and the probability of discordant pairs which the ordering of A and B are in disagreement all over the number of pairs. So in simpler terms, the population parameter gamma, it quantifies the relationship between agreement and disagreement in the ordering of randomly selected pairs of observation. Tells us how likely on average for two randomly chosen observations to be concordant or discordant pairs compared to each other. So using the sample, the population parameter gamma is estimated using the gamma statistic G. A positive value for G suggests that concordance among pairs of agreement in ordering is more likely than discordance among pairs, while a negative G indicates that discordance is more probable than concordance among pairs. So for the data, it consists of two sets of ordinal variables with K categories under variable A and R categories under variable B, with n overall n observations, and it can be constructed into an R by K condensity tables. And here are the following notations. A sub j represents the jth category for variable A, which are the column variables. V sub I represents the ith category of variable B, which are the row variables. And n sub ij is the observed frequency of the ith row and jth column. R sub I is the ith row total, and C sub j is the jth column total. Now we will first introduce the following sum of frequencies needed to compute for the gamma statistic. So sa table na to, we will refer to the n sub ijth cell frequency, yung nasa gitna, yung n sub ij. So n minus ij is the sum of all frequencies on the left side and below the n sub ij itself. And n plus ij is the sum of all frequencies on the right side below the n sub ij itself. So for the gamma statistic, itong dalawang frequencies muna ang kailanganin natin, and we will discuss m plus ij and m minus ij sa susunod na measure of association to be introduced. So to solve for these sum of frequencies, we'll have an example using the contingency table shown. So the first step is to take note of the n sub ij frequencies and disregard the column totals and row totals. So to solve for n plus ij, we will construct another table, which we see here on the right side. Recall that n plus ij is the sum of all frequencies on the right side and below n sub ij itself. So all cells na nasa pinaka-right and pinaka-bottom, i-zero out natin siya sa n plus ij table since wala na tayong frequencies na ma-add or makikita sa right side and below niya. Now, when getting n plus 1, 1, we refer to the n sub 1, 1 cell, which here is yung 34. We now look at the cells which are on the right side and below the cell. Then we get the sum of all these cells frequencies. We get 725. And we place the sum of these cells sa n plus 1 cell ng n plus ij table. Following this pattern, we have the following n plus ij table. So solving for n minus ij, ganun ulit, we will construct another table for n minus ij. And recall that n minus ij is the sum of all frequencies on the left side and below n sub ij itself. So, ngayon naman, all the cells sa pinaka-left and pinaka-bottom is zero out natin siya sa n minus ij table since wala tayong frequencies na ma-add or makita sa left side and sa baba niya. Now, when getting n minus 1, 3, refer to n sub 1, 3 cell, which here is 88. We now look at the cells which are on the left side and below the cell. Then we get the sum of all these frequencies in the cells. We get 358. We place the sum of these cells sa n minus 1, 3 cell ng n plus ij table. Kita natin here. And following this pattern, we have the n minus ij table. Now that we have obtained the sum of frequencies n plus ij and n minus ij, we can now calculate for the total number of concordant pairs and the total number of discordant pairs in the data. To get the total number of concordant pairs, we multiply the n sub ij table with the n plus ij table and take the sum of its products. So from the previous example, we get this from row 1 and column 1, you get 34 times 725, and that's equal to 24 times 650. And for row 1 and column 2, you get 53 times 476, which is equal to 25,228. And for row 1, column 3, we get 0 since yung third row ng n plus ij table is naka-zero out na siya. So, taking the sum of its products, we get 99,566 concordant pair, total number of concordant pairs. And for the number of number of discordant pairs, we multiply the n sub ij table with the n minus ij table and take the sum of its products. So in for the row for row 1 and column 1, we get 0 since yung column 1 ng n minus ij table is naka-zero out na nga. And yung for the first row and second column naman, we get 34 times 109, which is equal to 3,706. And for the first row and third column, we get 53 times 358, which is 18,974. Then, so taking the sum of the products, we get a total number of 43,096 discordant pairs. So for the assumptions of the gamma statistic G, the data must be measured at least on an ordinal scale. Second is the total variables must have a monotonic relationship, which exists when either the variables increase or decrease in value together, or as one variable decreases in value, the other decreases. Third is variables are treated symmetrically. So hindi mo kailangan ditong i-distinguish kung alin yung dependent or independent variables. And fourth, n should be sufficiently large since later on we will be using normal approximation sa hypothesis testing.
Hi, this is Jessica Perzo, and I'm here to discuss about the procedure and remarks of the Goodman and Kruskal gamma statistic G. So, we start by forming the contingency table from two sets of ordered variables. We can use a sub 1, a sub 2, all the way up to a sub k, and b sub 1, b sub 2, all the way up to b sub r. So the table should look like this. We have a r by k contingency table. So you would notice here the sum of frequencies that were just discussed. And we have big M sub ij plus, which refers to the sum of frequencies above and on the left side of the ij itself, such as this one. Next, we have big M sub ij minus, which are the sum of frequencies above and on the right side of the ij itself. We have big N sub ij minus, which refers to the sum of frequencies below and on the left side of the ij itself. And we have big N sub ij plus, which are the sum of frequencies below and on the right side of the ij itself. You would notice here in gamma statistic G that we mostly use these two big N's. And these two big M's, on the other hand, would be used as well for the next topic, sovereignty. So this is the formula for G. We have n sub c minus n sub d all over n sub c plus n sub d, where n sub c is equivalent to the summation of small n sub ij times big N sub ij plus for all ij values, as this refers to the number of agreements or concordant pairs. Next, we have N sub d, which is equivalent to the summation of small n sub ij times big N sub ij minus for all ij values. And this refers to the number of disagreements or discordant pairs. Next, to test for the significance of G, we have the null hypothesis that gamma is equal to 0 versus the alternative hypothesis that gamma is greater than 0, gamma is less than 0, or gamma is not equal to 0. We compute for Z here with this formula. So we are still using the test statistic G as well as N sub C and N sub D. And we note that when the null hypothesis is true, Z has an asymptotic and 0, 1 distribution. It is also important to note that this kind of looks like large sample approximation already. So this is because the gamma statistic G follows a sampling distribution that has a large sample approximation. So here are the decision criterions. For the alternative hypothesis that gamma is greater than 0, we reject H null if C is greater than or equal to Z sub alpha. For the alternative hypothesis that gamma is less than 0, we reject H null if Z is less than or equal to negative C sub alpha. And for the alternative hypothesis that gamma is not equal to 0, we reject H null if the absolute value of C is greater than C sub alpha over 2. And as always, we use table 8.1 for these critical values. Moving on to the remarks. First, in setting up the contingency table, the sets of ordered variables must be arranged in order of its magnitude increasing. Since we are interested in computing for the concordant and discordant pairs, there is a need for arrangement and um, order. Next, the gamma coefficient G ranges from negative 1 to 1. So the closer G gets to negative 1 or 1, the stronger the relationship among variables. G equals 1 indicates a perfect positive correlation, while G equals negative 1 indicates a perfect inverse correlation. When G equals 0, this means that there is no association between the variables. So we can illustrate G equals 1 or R equal to K. So in this 3 by 3 contingency table, when the diagonals from the upper left all the way up to the lower right are non-zero, while the rest of the values are 0, this will give us G equals 1 actually. So feel free to verify with any values that you want. And this should give you a gamma statistic of 1, which indicates a perfect positive correlation. While for R not equal to K, in this 3 by 4 contingency table, um, if the pattern of your table looks like this, with these values not equal to 0, and the others are 0, this should give you G equals 1. Now for G equals negative 1, or R equals K, in this 3 by 3 contingency table, it also deals with diagonals. But this time, you're starting from the upper right all the way up to the lower left, while the others are all 0. So if these diagonals are non-zero, you can test that it will give a gamma statistic of negative 1. So feel free to verify this as well. And for R not equal to K, we have a 4 by 3 contingency table. And if these values are not 0 and these are all 0, it should also give you G equals negative 1. Next, when interpreting what the value of G means for the relationship between the variables, a scale was given by Rhea and Parker in 1992, as noted by Feldman. The scale looks like this. So we have negligible, weak, moderate, relatively strong, strong, and very strong. And please take note of the brackets so that when we have values that are usually with 4 decimal places, we will know exactly where it belongs. And we can include these adjectives in our interpretation. Next, a special case when computing for the gamma coefficient given a 2 by 2 contingency table is what is referred to as Yule's cube. So if our table looks like this, in previous tests, like for chi-square test for independence or for exact tests, we usually label our values with A, B, C, and D. And with Yule's Q, this is the formula. We have A times D minus B times C all over A times D plus B times C. This is just a variation of G. But since it is a 2 by 2 contingency table, we have A, and this is the only um, big N sub ij plus. And while for discordant pairs, we only have this B times the big N sub ij minus, which is C. Hence, we have this formula.
Good day, everyone. This is Feikaya, and to better illustrate the concepts behind Goodman and Kruskal's gamma statistic G, let me guide you in answering the following example. So, table below cross-classifies job satisfaction with age for a recent general social survey. The GSS is a probability sample of Americans conducted every other year. Both classifications are ordinal as measured, with the job satisfaction categories being 1 equals not satisfied, 2 equals fairly satisfied, 3 equals very or completely satisfied. Determine the degree of association between job satisfaction and age of respondents. Test at alpha equals 0.05 whether job satisfaction tends to increase as age does. So, a contingency table of the problem above is given in this. To compute for G, we use the following formula. G is equal to the difference of the number of concordant pairs and the number of discordant pairs all over the sum of the number of concordant pairs and the number of discordant pairs. To get n sub c, we have to compute for the summation of the Nij times Nij plus. So ito yung contingency table natin for Nij, and ito rin yung table na nagsa-summarize ng values ng Nij plus. For those who might ask paano nakuha yung values doon, ito ang ating step-by-step procedure. Recall natin na to get Nij plus, we'll have to look at the values at the right side and at the bottom of the corresponding ijth cell. So for N11 plus, ang ating N11 is 34. Titingnan natin itong values na highlighted in yellow, sila yung nasa right side and bottom ng 34. So we have 174, 304, 75, and 172. Kunin natin yung sum nila. This will give us 725. Gagawin lang natin yung same procedure na yon para naman sa other Nijs. And mananotice din natin na yung rightmost column and yung pinaka-bottom na row ay puro 0 na. Ito, using the values here, plug in lang natin siya sa formula na to. We have 34 times 725, 53 times 476, and so on, giving us a 99,566 number of concordant pairs or also the number of agreements. Para naman sa ating number of discordant pairs, halos same procedure lang siya before, pero this time, Nij minus na ang ating imumultiply sa Nij. Para kunin yon, in getting the Nij minus, we have to look at the values at the left side and below the ijth cell. So, para sa N12 minus, ang N12 natin ay 53. Titingnan natin yung values at the left side and below it. So, we have 80 and 29. Kunin lang ulit natin yung sum. We have 109. Follow yung same procedure para sa other Nijs. and plug in itong values, we have 73,943 number of discordant pairs. So, using the values na na-compute natin sa NC and ND, lagay lang natin siya dito sa formula ng G, we have 0.1476753367. So, how do we interpret this? Previously, mayroong pinakita si Cheska na table para mag-guide sa atin sa pag-interpret ng values ng G. And yung 1.477, pasok siya sa range na nagsasabi na merong weak positive association between job satisfaction and age of respondents. This means that only a weak tendency exists for job satisfaction to increase as age increases. In testing the hypothesis, we have the following HO. Gamma is equal to 0, meaning no association between the variables, versus our alternative hypothesis na gamma is not equal to 0, meaning there is a significant association between the variables. For this one, we will have to use Z as our test statistic, which is equal to G times the square root of NC plus ND all over N times 1 minus G squared. Nakuha natin previously yung value ng G, NC, and ND. Plug in na lang natin sila here sa formula. We have 1.958 and so on. For the critical region, we will reject HO if the absolute value of Z is greater than or equal to Z alpha 0.025 kasi dinivide na sa 2 yung alpha since this is a two-sided test. And rounding off, we have Z absolute value of Z is equal to 1.96 and equal siya sa ating critical region, so we will reject HO. At 5% level significance, there is sufficient evidence to say that job satisfaction tends to increase as age does. And for our p-value, we'll just compute the probability that the absolute value of Z is greater than or equal to 1.96, which is 0.0250, less than ito sa ating alpha na 0.05, so reject HO rin. For our software application, we used 3 functions. Number 1 is the Goodman Kruskal gamma, and ito ang nabigay niyang value, 0.1476753. Same naman siya sa manually computed value natin. For our second option, we used the function capital GK gamma, 0.148. So nag-round lang siya up to 3 decimal places. Same lang din naman. And for our third option, we also have GK gamma, which gave us gamma statistic now 0.1476753. Same lang din naman, yung number of decimal places lang nila yung nag-iba. And tumutugma sila lahat sa ating manually computed gamma statistic. That is all.